key is back to work. Let's see what I got. Why am I not writing? I got to be writing. All right, we're ready. This is day 2 of Unit 3. And Mr. Key is ready to rock and roll. All right, kids. You need to understand a little something about quadratic functions. Right? They all generally have the shape of a parabola. So, sometimes they go up, sometimes they go down. But you have to understand what's going on. So we're going to start to look at these problems in context, which is to say, real-life problems. Sounds like fun! Hey, look, guys, seriously. If you haven't subscribed yet, please subscribe. You're watching my channels, you're watching my videos. Hit the subscribe button for me. Do me a favor. Help me out, right? I'd help you out. Second thing, if you really, really like my videos because, you know, this striking bald head of mine, or you're just getting a lot out of them, you can always donate. I'm in need of a new computer. Do you see? My computer's really old. So that's me. That's my done. But do hit the subscribe button, please. That helps me out a little bit. I'm not going to get wealthy from this, but I would like a new computer. I got to convince my wife to give me one. If my son wasn't in such an expensive school, yeah, that's right, Lucas, I'm blaming you, I'd be all right. So before I even think about this problem, let's just get going because this is going to be a long video. There's a lot going on here. Before I think about this problem, I want to look at a couple things. We got a football player attempts to kick a football over a goalpost. So we're talking about the path of a football. So before I even go any further than that, let's think about this. Football, sitting on the ground. There's a football sitting on the ground, right? A little bit. Here's my sick drawing of a football player. I'm not even going to attempt to draw it. And we got our goalpost over here somewhere. Right? Great drawing. So the foot's going to come in. It's going to kick the ball. It's going to go up and up and up and up. And hopefully it goes through there. And then it's going to come down and down and down. Well, that drawing kind of sucks. But I hope you see. Let's see if I can erase that. I don't want to erase that football. It took me a long time to draw that football. But, you know, let's say the goalposts were here. I know that's make it look more realistic. Okay, so he kicks the football and it goes up and it comes down. Well, what is that shape? Obviously, it's an upside down parabola. When a ball goes up, it usually falls back down, and it sometimes can follow the shape of a parabola or a quadratic. And so I don't know what I just clicked on. Oh, there I am. So let's get rid of this. And now let's start talking about what we're going to look at. Now, this is a funky looking function. It's kind of crazy looking. Here it is right here. H of x, height of the ball. I should have seen h of t really. Oh no, well x is the horizontal distance. Oh, so it's distance. Okay. X is the horizontal distance from the kick, and h of x is the height of the football. Both are measured in feet. Now, you'll notice there is no y-intercept on this. Well, okay, there is a y-intercept. What is my y-intercept since there's no constant value? Oh, good, 0. So doesn't that make sense? Football starts at the ground, right? And eventually it's going to end back at the ground. I just don't have a clue what my window is going to be. No idea. So I want to go take a look at it on the calculator. So let's go take a look. I forgot. I'm going to have to toggle back and forth. It's negative 1 2/25. So control division. Negative 1 over 225 x squared plus 2/3 x plus control division 2 over 3 x. Okay, so I'll hit enter. Ouch, my foot. What the? It looks like a straight line. Let me draw a straight line. Let me just draw a straight line because it's a straight line. Heck no. Can I grab these axes and slide them over? Oh, I can shrink them. See, I can grab them and shrink them. Wait a second. Wait a second. Does that look a little bit better? Maybe that looks a little bit better. I can change my window so it makes more sense. So it looks like, you know, Ball's coming up and it's going down. There's where the path of the thing is. I just don't know. It looks like I got to go out to maybe 200, maybe 180, and go up to, I don't know, if that's 108, it looks like it might go up to a third of that, which is like 36 feet. Does that make sense? A football being kicked, go up about 36 feet, kind of. So I can go into my menu and go into Windows and Zoom and Windows settings and say, okay, I want my X's to go from, let's say, 0. Well, I don't like 0. I'm going to do, why can I not type? Oh, I forgot. How about -10? And then we'll go to 180. Actually, you know what? I'm going to make this -18. You'll see why. Because then I think it'll auto-pick something nice for me, maybe. And then I'm going to go, I don't even want it to auto-pick. I want to pick something. Let's go 10. And then I'm going to pick, now this was going to go to 36, right? So then I'm going to pick like -4 to, let's say, 40. And it'll auto-pick something nice. So how about that? Oh, man. Well, that's a much nicer way to look at it. Ball goes up, comes back down. It's a parabolic shape. So if I'm looking at my... I have no idea what happened to my notes. Well, that's interesting. My notes just kind of went away. Oh, they're coming back slowly. Told you guys I need a new computer, didn't I? Son of a... Alright, let me close out of this. Maybe that'll help. And then, where does it go? Where's my OneNote? No, I don't even know where OneNote is. There it is, OneNote. But that's going to open up. That's not going to open up the right one. Oh, no. How about this? I'll click on that. Oh, I think that's the wrong one. So Microsoft Office 2010 has a OneNote tablet app. I don't want the OneNote tablet app. I want OneNote. Hey, Cortana. OneNote. You gonna find it for me, baby? Man. Hey, Cortana. Open up OneNote. 2000 and...
Which one do you want?
Yeah.
OneNote 2013.
Yeah, that's what I want right there. Ah, we're in better shape. Yes, make it default. Yes, I know I can go back in there. Oh, silly thing. Okay, looks like we're back. Gotta love Windows 10. This is already going to take long enough. Now I got problems with that. Okay, so we're going to take a look at our window. And so, you know, over here, I'm thinking... draw. All right. I like... Now, you know, seriously, if we're looking at it the way the graph looks right now, our X-min would be 0. I like to put -10 because I kind of like to see the axes. If you don't do that, not so much. And then I picked 180, and I did auto, but, you know... And then the Y-min we went from 0 to 40. All right. And table start, table end. Let's see. Let's go back into, where's my calculator? So we go to menu, table. I never used table start. Let me go back into it. Menu. I'll just go back to it. Table. Settings. All right, kids. I hadn't used this in a while. All of a sudden, I blanked on it. Sorry about that. So anyway, I also want to get into like my table settings because these are kind of, you know, maybe not the most useful numbers. Do I, you know, I want to go, you know, do I want my X values to go up by 1 every time? I mean, you know, that doesn't really seem the most useful since I got to get to like 180, right? So I'm thinking if it looks like when I go up by 3s, every 3 looks like a nice number almost. But whatever. Honestly, maybe 10s might be nice. I don't even know, right? So let's go, let's see, how do we get to that? Well, we go to menu, that's where I couldn't remember how to get to. Go to table and then go to edit table settings. And so we'll start our table at 0. And maybe to make more sense of it, let's go up by tens. So now, you know, I can plot, you know, 0, 0, obviously, 30, 16, 60, 24, 90, 24, 16. So now we're seeing a few things. We also probably see that somewhere between 90 and 120, which is a difference of 30, somewhere, wait, not between those two. Between 60 and 90, notice there's somewhere around here, probably at 75, looks like it might be our vertex. Do you see how we got this pattern going? So maybe I want to go up by 15s, not by 30s, and I think that maybe make more sense. Go into menu, tables, and edit table settings, and maybe instead of going up by 10s, we'll go up by 15s. And I think what we'll see is we'll get much better numbers. Oh. No, see, now we lost all our good numbers. So maybe what we want to do is go up by 5s. So sometimes this is just playing around with what makes more sense. And I get some good numbers. Boom, boom, boom. I shouldn't be in the zero. So 15 is a good number. 30 is a good number. 45 is a good number. 60 is a good number. 75, I'm pretty sure that's where our maximum is. Looks like our maximum height was at 75. What was it at 90? 24, 25? So now I can plot this thing better, right? Now I can actually go over here and I can say, okay, it's going to be 0, 0, 15, 9. And I know I got to get up to 25 on my graph. I'm going to get back to my graph. So I need to get up to 25 on my graph. And I know I need to get to, let's see, how long before it goes back down? All the way back down to 0. Well, at 135, it's 9. And this, by the way, 1e to the negative 12. Anytime you get to e to the negative, that's just a computer estimation error. At 150, it's back at 0. So if I'm looking at what I'm doing here, I'm going to say, okay, I need to go from 0 to 150. 0, somewhere over here is going to be 150. Probably should count the number of boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so, oh, this was 15? Is that in the middle? I guess that's middle. That's 15, so that would be 75, right? That's perfect. That's where the vertex is going to be. Now, I only got to get up to 25. I'm going to guess there's probably 20 boxes here. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we'll probably make every box 2. So I'll go 4, 8, 16, 20, 24, 28. I don't have to go any higher than that. Okay, so 0, 0 is a good point. Go back. I know 75, 25 was a good point. So that's 20, that's 26. So 75, 25 would be right there. And it was 24. But what was it? When was it at 24? It was 24 at 90 and 60, right? So each of these is what, 5? No, each of these is 3. 15, no, each of these is 5. So at 60, it's 24, which is 12 boxes. That's right here. It was 24. And 3 boxes up. And then, well, that's annoying to go back and forth to. And then at 3 boxes down from there, which is 45, it's 21. Go another 3 boxes down, it's 21. 21 is right there. And we're going to go 3 boxes up, and we go 1, 2, 3, and 21 there. I went 1, 2, 3. What the heck did I do? 3 boxes. Not this one. Ignore that one. I got to get rid of that one. All right. And then the next one would be 16 at 3 more boxes down. 1, 2, 3 at 16. And I know next 3 was 9. And then 0. So 1, 2, 3 down to 16. 1, 2, 3. I missed one. That 1, 2, 3. I went up to, and then 1, 2, 3 down to 9, and then 0. So there's the graph or the plot of my football. Something like that. Screw that up a little bit. Sorry, can't draw it. But that's an easy thing. So determine the vertex of my parabola. Why does this keep showing up? I don't know why. The vertex was 75, 25. Now I could have used my, formula for the axis of symmetry. Boy, that would be kind of a pain in the neck. X equals negative b. So let's see. What is b? 2/3? So b is 2/3. So it's negative 2/3 all over negative 1 2/25. Negative 1 2/25. Well, that's positive. And then you multiply by the reciprocal, which is 225 over 1. 25 goes into 225. 25 goes into 225. 75 times? That doesn't make any sense. Oh, shoot. It's 2 times. It's 2a. So this should be a 2 in the top. So multiply by the reciprocal. The 2's cancel. And 3 goes in there 75 times. Or you could have just done the math on your calculator. Plug 75 in and you're going to get 25 out. Now, what does it say? Interpret the meaning of the vertex for the context of this problem. Well, remember, this, the x value, is the horizontal distance. So it's traveled 75 feet. Is it feet? Are we talking about feet? Feet. When it's traveled 75 feet on the field, or 75 feet away, it will be at its maximum height. And the maximum height will be 25 feet in the air. So this is the air. So the y part is the how high it's gone, and the x part is how far down the field it has gone. The goalpost is 10 feet high and 45 feet away from the kick. Will the ball be height enough? So what I want to do with that is I want to go back to this thing. And they said the height of the goalpost is 10 feet. So what I want to do is I'm going to grab a different color. And I'm going to grab blue. And I'm going to highlight 10 feet. And I'm going to do a big, fat blue line if I can. So this is 8. Well, there's the problem with my graph, by the way. So this should be 12. This should be... so let me redo this. I apologize. I'll tell you what, I'm going to pause it real quick so you don't have to watch me do this. All right, I'm back. So I'm going to grab a blue pen now. I fix this. So what I want to do is the height of the goalpost is 10 feet. So this represents the height of the goalpost. And it's 45 feet away. So remember, we counted these as 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45. So this would be 45 feet. Well, at 45 feet, the height of the ball is 20 feet in the air. So will it clear the goalpost? Yes. Now, did they kick it down the middle? We don't know. But we certainly will clear the goalpost. So the answer to that question is, I think it was just yes. Yes. And I justified it with my graphing above. All right, let's take a look at another one. So here's another shape. Let's see what this is. The height 8 in feet of a ball will reach when thrown in the air is a function of time given by this equation. So let's first take a look at this equation. First of all, we're going to throw a ball in the air, and of course it's going to come down. But what I want you to notice first is this 6. This 6 means that it was started at 6 feet in the air. So my... however I'm going to start, it's like a 6-foot person holding it or throwing it above their head or something like that. So it's starting 6 feet in the air. So let's go take a look at this thing graphically. And I've specifically picked weird numbers. Not weird numbers, but remember, go out of this, don't save it, go back in. And then let's go. What are we doing? Negative 16x squared plus 30x. So I hate that. So negative 16x squared plus 30x plus 30x plus 6. So I graph it. Totally useless. You know, I can spread this out. Bring this down a little bit. Can I spread that out? Oh, I guess it's going to fix it. That's just, I hate that. So we're going to go into menu. Let's get rid of this thing. Let's go see. Let's see what we got here. Let's see. Menu. Windows and Zoom. Let's talk about our Windows setting. Hold on. Let's take a look. Sometimes if I just look at trace, I can go menu trace, graph trace, and it starts at the y-intercept, and I just keep going to the right. It will eventually tell me what the maximum is. It looks like the maximum is about 20 feet in the air. And it'll also, I can go over here and it'll tell me another root, or my zero. My other zero is at, it looks like 2 seconds away. So it looks like I want to go from like 0 to 3 seconds. So menu, zoom, nope, yeah, Windows zoom settings. And I want to go from, let's go 0 to 5 seconds. And it'll auto pick nice for us. Now let's just pick 1. Let's just go by ones. And then I know I got to go 0 to, let's say, 25. Do you see how I can't see the axis? This is why I don't like picking 0 as one of my numbers. So I go back in. I'm going to go back in. I hate that. I hate that I can't see the axis. So I'm just going to go here. I'm going to pick -1. And here I'm going to pick -5. And then click OK. And then to me, it's a lot easier to look at. Right? It's just a lot easier to look at. Something like that. And I'm like, okay, it starts at 6. And after about 2 seconds, it's back down at 0. Not exactly 2 seconds, but about. Looks like 2.05728 seconds. And this, see the e to the -12 again? That's a 0. So maybe what I want to do is look at the table. Control T. And, you know, it's not a very useful table because now I'm going 0, 1, 2, and now I'm in negatives. And it looks like at 1 second it might be at its maximum, maybe, I don't know. So I think maybe what I want to do is do menu, table, edit table settings. And maybe I want to go from start at -1, that's fine. Actually, we're going to start at 0 because for the table settings, it makes no difference. And I think maybe 0.1 might be good seconds to go. And click OK. So now what I'm going to look at now is, okay, now I can see, okay, 0.5, it's at 17 feet. At 1, it's at 20. At 1.5, it's at 15. At 2, it's at 2, and then it goes right to 0. Then it goes negative. We don't care about that, right? Because that's not in our problem. But it's going to be right around 2. Oh, why does it keep doing that? I don't understand. That's all I got to do is go from page to page and get off my screen. Get off my screen. All right, so let's talk about our scale then. Notice I'm using the same exact graph paper, 0 to 0. I got to get up to 20. There's 20 boxes, right? There's 20 boxes. So 2, 4, 6. Use your scale appropriately. I should be able to see detail. I shouldn't see some silly little graph slammed down there, and this is not going to work. 14. Oh, obviously we don't have quite 20 boxes. So I'll just use every box is 1. Wait, I can't do that. I'm going to just decide to 1, 2, 3, 4, Oh, I forgot every 17. Well, that was dumb. So I'll make every box 2 again. 4, 2, 6, 8, 10, 12, 14, 16, 18, 20. That's probably good enough. That's okay. And then I don't need to go all the way across. Like I did on the last one, I felt that was pretty good. It just worked out well because there was 30 boxes. 30 boxes, and I made every box 5. That was perfect. Now I got to get to 2 seconds. So maybe 1, 2, 3, 4, 5. Maybe what I'll do is make every one a tenth. 1, 2, 3, 4, 5. 1. 1, 2, 3, 4, 5. 1.5. And 1, 2, 3, 4, 5, 2.0. And then right after that, 2, 2, 3, 4, 5. It actually drops and it's negative. So I don't have to go past that. But you see, it's going to be able to see it more. So what I want to do is I want to find the vertex of this thing. I want to find out when, determine the vertex. So I could do this, x equals negative 30 over 2 times negative 16. Well, what this turns out to be is negative 30 over negative 32, or 15 over 16. It's really, really close to 1 second, but it ain't quite 1 second. Let's just see what it is. 30 divided by 32. 30 decimal point divided by 32. 0.9375. So just before we get to 1, we're at the vertex. And that vertex is, so I would like an easier way to find the vertex. I think I go over this on the next page, don't I? Oh, I do this on a different things. So what I'm going to do is I'm going to use the trace feature of this calculator. This calculator's got a nice trace feature. Menu. Oops, I should be in the graph mode. Gotta be in the graph mode. So let's get rid of that. Control T, and then go into Menu, Trace, Graph Trace. And what I want to do is, by the way, it almost always. Oops, I was already in graph trace mode. There it is, max 0.9375, 20.6025. Now this is going to be a quick sketch. So 0.9, let's see, that's 0.9, that's 0.93, so it's about halfway in there, and it's a little bit over 20. So that would be my vertex. Now what I want to do now is probably go into my table and start looking at some nice points. And somehow my table got messed up. 0.1, click OK, and then we're going to go down. So at, let's see, at 0.5, it's 17. Why do you keep coming back? At 0.5, it is 16, 17. That means at 1.5, nope, that doesn't mean that. What other points do I have? 1, it's 20. So at 1, we're at 20. Why do you keep coming back? At 1.5, it's 15. And I think that's about it. No, at 2, it's 2. Now, just because I want to see a few more points, I'm going to estimate some of these others. Oh, it's 0. Oh, that's right. We had 0 at 6. Oh, so we're in pretty good shape. We can get a good sketch of this thing. Something like that. Okay, so my vertex is 15 over 16, comma. Why do I have all this stuff open? Don't need that open. That's probably why my computer's dying. Control T, let's get out of that. And we said 20.0625. Good enough estimate. 20.0625. Good enough. Interpret the meaning of this vertex. Well, here's what I would like. After about 1 second, the ball is at its max height of 20 feet. That's about what that means. Now, is it exact? It's not quite exact, but it's exact. You understand the meaning of these things. That's what we're trying to get at. Can you understand the meaning? Jimmy is trying to throw the ball to his friend Brendan. The ball will be above Brendan's head after 1.5 seconds. If Brendan can reach up to 10 feet in the air, will he be able to reach the ball? Jimmy is trying to throw the ball to his friend Brendan. The ball will be above Brendan's head after 1.5 seconds. So basically, Brendan's sitting there, and it's going to be right there, ready to go in his glove, above his head. And it's after 1.5 seconds. Can he jump up 10? He can jump up 10 feet. So we got to figure out what's happening at 1.5 seconds. So what we'll do is we'll grab my pen, and I'm going to grab green, and I'm going to go up 1.5 seconds. 1.5 seconds. And at 1.5 seconds, this ball is approximately 15 feet in the air. And he can only grab up to 10 feet. Is he going to be able to grab the ball? The answer to the question is clearly no. All right, let's move on. How many of these do I have? 3, 4, 5. All right. Wow, holy crap. All right, we're not going to be able to get... Well, you're not going to want to do all these, but let's do... Hopefully you start to understand it. So, again, we have another parabola. 30 minutes already. We have another parabola here. It's just written backwards. That's actually the B term. That's actually the A term, so it is an upside-down parabola again. And it says the equation in watts and power of a circular, of a 120-volt circuit having a resistance of 12 ohms when the current I is flowing through the circuit. On the set of axes below, graph the function W of I. So I have no idea what any of these things are. I know that W stands for watts. That's what the W stands for. And I is the amount of current. I stands for the current. And yes, this is a pretty accurate problem. But I have no idea what this what's this going to graph to look like. Let me get rid of the garbage. And we'll go back in. And we're doing 121x. Or 120x. Damn. Darn. 120x. Yes, you can't use I. Minus 12x squared. And lo and behold, holy mackerel, looks like a vertical line going straight up in the air. Wait a second, what is this? Oh, it's coming down. I just have no idea how long it's coming down. But now look, somewhere between 0 and 12 seconds, excuse me, 12, it's not seconds, this is 12 currents. Ooh, we got to figure out what the units for current is. I believe it's amperage. 12, somewhere around 12 amps. So somewhere around 6 amps, we're at the highest wattage we're going to be at, but I can't see that. So I don't know. I'm going to go into menu, trace, because I like to use trace to kind of get an idea. Oops, menu, trace, graph trace. And I just go until we get to the max. Oh, there we go. Maximum. The maximum is at 300. So at 5, it's 300 watts. So if I'm going to look, if I want to really look at this, I'm going to go menu, zoom, window settings. Now, so 5 is the axis of symmetry. I want to go a little bit past that. So I'm going to go, how about we go -2 to 12. And it'll pick a nice scale for me. And I'm going to go from -30. Let's go from -35 to 350. See, it's like 10. it's such a nice scale. And I can see the whole picture. So I know I have to get up as high as 30 and over to 10. So I'm going to go back to my graph now that I know what this thing is going to look like. 0, 0. I got to get to 10. So 2, 4, 6, 8, 10. Let's make that 5. 2, 4, 6, 8, 10. 10. And I know I'm going to get to 300. So let's make every, and there's 17 of these things, like make every 5 100. So that makes every 120. 1, 20, 40, 60, 80, 100. 20, 40, 60, 80, 200. 20, 40, 60, 80, 300. And looks like we're at, wait, 1, 2, 3, 4, 5. 1, 2, 3, 4. I'm off a little bit. I knew I was off a little bit because there's only 17 boxes, and I had 3 left, not 2 left. So 1, 2, 3, 4, 200. 1, 2. I think I did it again. 1, 2, 3, 4, 5. No, 1, 2, 3, and then this is 300, and then this is 340. So I know I'm not going to get up that high. So at 5, it was 300. Now we'll get Control T. I think this will give us, I think this will have a nice table. I don't think we're going to have to change the table settings. Yeah, we're in good shape here. So 1 is 108. Well, at 0, it's 0. At 1, it's 108, so that's somewhere about in the middle there. At 2, it's 192. So somewhere around there. And at 3, it's 252. That's 240, 250. And at 3, it's, or 4, it's 288. So that would be 280, 288. And then we'll just come back down. And match these. Now these are going to match only because, well, now they may not match exactly. Are they going to match exactly? 192, 288, 300, 288, 252, 198. Oh, good. 108 and 0. So there it is. There's my graph. Boom. Oh, this was off. That's why. Should have been here. Second time I've been off. Okay, so let's see what's going on. Now, first of all, we want our watts, our power. Actually, this is not power. This W is power, and it's measured in watts. I is the current, and it's measured in watts. W is in watts. I, 120 volt circuit having a resistance of 12 ohms when a current I is flowing through the circuit. I is in amps. I didn't put it in the problem, but I is in amperage. So determine the vertex. Well, the vertex is 5, 30. What does it mean? At 5 amps, we get a maximum power of 300 watts. So how many ohms are flowing? It's not ohms. Ohms is resistance. It should be amps. Sorry. How many amps are flowing through the circuit for it to have a power of 0? Well, that could be at, well, you can't have 0. They're not talking about 0 amps. It wants to know how many. So in this case, it'd have to be 10 amps would be flowing. Right, because up here, ohms is resistance, and that's the resistance in the wire. All right, done with that problem. Let's move on. A rock is thrown vertically from the ground with a velocity of 24 meters per second squared. So that's an acceleration, and it reaches a height of that. So we're going to graph this thing. So what we're doing was we're throwing that thing in the air. Now, as time goes by, it's going to go higher, 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 higher. It's going to stop, and then it's going to come back down. So it's almost going straight up and straight down. So there is no real horizontal distance, which is why this thing doesn't measure horizontal distance. The X axis is not a horizontal distance, it's actually time. So as time progresses, it goes up and then comes back down. We just don't know how high it's going to get. Now, I do know one thing. It's being thrown by a kid because it's going to start at 2 feet in the air. Because my height, when it starts, is 2 feet in the air. Now, if it's 2 feet in the air, it's got to be thrown by a kid. Actually, by a really little kid. So, see where I am. 0 and 0. I just don't know what it's going to look like. So, it's negative. Let's just not save. And then we're going to go back in, and we're going to go 2 plus 24x minus 4.9x squared. And hit enter. Oh, okay. 1, 2, 3, 4, 5. It looks like it's going to take 5. It looks like 2.5 might be the vertex. Let's go see how high this thing gets. So we'll go to trace. And ding, 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 ding. Wow, it gets way up in there. There's the maximum, about 31 feet in the air. 22.44 seconds and almost 31 and a half feet in the air. So if I'm going to pick a nice window to look at, let's hit Control T. Control T. All right, escape. Control T. Menu, table. Let's go edit the table settings. We'll start at 0 and we'll go up by, let's go 0.5 seconds, just to kind of get more of an idea. And, oh, if I want to look at this thing better, well, whatever. So, why is it 0? Does it say 2.4, 12.54? Something's not right. Escape. Oh, it's 0. It's 2. It's 0.5. It's 12.75. Okay. So I know it's got to get around 30 feet in the air, and we're going to go for 5 seconds. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. And we got to get up to 30, so let's make this 5, 10, 15, 20, 25, and 30. And we'll go to 35 just for fun. Okay. So at 0, we said it was 2. That's about here. At a half a second, it was at 12.8 or almost 13. So there's a half a second. It's at 13. And at 1 second, it was 21. So at 1 second, it was, let's see, that's 22. It's about halfway. And at 1.5 seconds, it's at 27. And at 2 seconds, it's 30.4. And at 2.5 seconds, it's at 31.4. And at 3 seconds, it's at 3 seconds, it's at 20. Why can I not see this? At 3 seconds, it's 29.9. And at 3.5, it's 26. And at 4, it's 19.6. And at 4.5, it's 10 point, it's almost 11. And just before, at 5, it's negative, so just before 5, so 5, it's just a little bit negative. So somewhere around there. All right, there's the shape of my graph. So let's just get going. What's the question say? How many seconds after the rock is thrown will it reach its maximum height? So after how many seconds? So that's the axis of symmetry question. So we're going to do t equals negative b over 2a. So in this case, it's negative 24 over 2 times negative 4.9. Remember, it's 2a, right? So I don't know what that is. I know it's positive. So 24 divided by, control division, 24 over 2 times 4.9. I just chose to get rid of both negatives. 2.44897 seconds. So 2.4489. You know, approximately 2.4 seconds. And we're good with that. Someone probably should have told you where to round to. What is the maximum height? Well, if I want to go to maximum height, I'm going to go menu. I'm going to do it in my graph. And I'm going to want the maximum height. Get rid of the table. And we said it was at 31.3878. So approximately 31.4 feet. How many seconds after the rock is thrown will hit the green? Approximately 5 seconds. Done. Home plate. That looks like the same function we used before, doesn't it? Negative 16 point. And the reason it's always negative 16 point is because the acceleration due to gravity is negative 32 feet per second squared. I'm assuming that has something to do with it. Where's that one? There it is. 30t plus 6. So it's close. Again, we're starting 6 feet in the air. You know, if you had to guess, how long would it take a ball to fly from outfield to wherever they're throwing this thing? Because I lost track of where we're throwing this thing to. What, 3 seconds? I mean, you know, certainly it's not going to be more than 3 or 4 seconds, right? So let's get rid of this garbage. No. What? And cancel. Get rid of this garbage. No. Go back into this. And we're going to do negative 16x squared plus 48x plus 48x plus 6. Graph it. Oh, forgot the negative. See how it's not going the right way? So let's go tab, up. Throw that negative in. Make it a lot better. All right, so there we go. And notice it starts. So I'm going to guess it's probably going to get about 30 feet in the air. So I'm just going to change the window. Sometimes I need to, because I'm thinking about it. So let's go x min. We'll go negative 2. Probably, let's go 6 seconds. That's way too long. Let's go negative 5. And let's go 30. Will that be enough? It should be about. Looks like this ball's going higher than 30. So maybe I'm a little wrong on that one. I go estimate a little bit up. Let's go 60. There we go. Now we can get a good view of it. There it is. So there's my table. I want to get a good graph of this thing. Let's see how long it takes. Let's see. So I would like to go menu, trace, and let's see what. And let's. Oh wow. 1.5 seconds. It's 42 feet in the air. That's kind of nice. 1.5 seconds. It's at. There it is. 1.5 seconds. It's 42 in the air. Is that the maximum? Wait, menu, trace. Oh, graph trace. I wonder why it's doing that. So 1.4, 1.5, 1.55, 1.6. Oh wait, 41 point, 41.8, 41.9, 42. So it's at 1.5 seconds. It's 42 feet in the air approximately. So that's about where our center is. So we got to get up to 42, and we got to get over to the 3 seconds. So 1, 2, 3 seconds. And we got to get up 42 feet in the air. So let's make every Oh, there's like there's 20 boxes, but let's make every one of these, I don't know, 5 again. 5, 10, 15, 20, 25. That's annoying. No, whatever. 30, 35, and 40. And we're starting at 6 feet in the air, so that's about there. At 1.5, we're at 42. That's about there. Where's my table? Let's go into my table again. Control T. I think I want to do a little bit more than that, so let's do every 0.5. Oops. Oh, just didn't show it. There it is. So at 0, we're at 6 again. That makes sense. At a half, we're at 26. So 1/2, we're at 26. At 1, we're about 38. At 2, we're at 1.5, we're at 42. At 2, we're at 38. And at 2, we're at 38. That's where I was getting messed up. And back. And at 3, we're at 6. So a little after 3, it hits the ground. So there it goes up. Damn, I can't hit anything. Comes back down. Notice at 3, it's back down where it started from. But after 3, it takes a little over 3 seconds to hit the ground. So in context, what's going on? How many seconds after the ball's thrown will it reach its maximum height? 1.5 seconds. Now that's according to the graph. Let's take a look and see if we can do it by manually. So negative b, so t equals negative 48 over 2 times negative 16. And if you did this in your calculator, it would say 3/2. Oops. It would say 3/2, which is 1.5 seconds. How many seconds after the ball thrown will it again be 6 feet in the air? Well, it comes back at 3 seconds. It's back to its own height. And if I wanted to, I can just graph the line 6 and see, oh, there it is. It hits at 3 seconds. Done. Oh, okay. So now we're going to do one more. We're going to do one quick regression analysis. And I know I haven't taught quadratic regression yet. We're going to do that later, but not much of it, I'll tell you that. So menu, we'll go into the spreadsheets. We'll call this X. We'll call this Y. Again, I gave you a tricky one. 1999, let 0 represent 1999. So this is going to be 0, 1, wait, 0, 0, okay, 0, 1, no, 2, 3, 4. Did we go to 4? I don't even know. 41,356, 41,356, 41,267, 41,267, 48,33, 48,33, 41,289, and 43,171, 43,171. Okay, so what we're going to do with this is we're going to do a little quadratic regression. Notice we're going to do quadratic regression. So we'll go into our, just like before, we go into menu, statistics, stat calculations, quadratic regression. You're going to tell it what your X list is. You're going to tell it what your Y list is. You'll notice that, again, it gives you the formula. The regression equation is ax squared plus bx plus c. So this time it's going to give you a, b, and c. So when I come back to my graph here, I got to write down A equals, B equals, and C equals. So A equals 3, 4, 5, 1, 4, 2. 3, 4, 5, 1, 4, 2, 8, 5, 7. 8, 5, 7. Negative 1,015. Negative 1,015.1 3714. 3714. And 41,543.08, 43.08, 571. 571. And let's say we're going to write it to round to the tens place. And I probably should have put that in the direction. So let's go to the tens place. So my function, let's see what this is. It lists the total number of AIDS cases per diagnosis from 1990 to 2003 United States. And so let's just do f of x. F of x is equal to 345.1 x squared minus 1,100 or 1,015.4 x plus 41,543.1, which is just about what year 0 was. Determine the appropriate window. Now, oh my gosh, well, it's starting at 41,000. So now time, so my x values over here should probably be somewhere between, like, I like to be able to see the window. So let's go negative 1 to, let's say, 10. That would be 10. That would be 10 years. Well, don't worry about the negative 1. About 10 years, we're going to see. But the y window is going to be kind of crazy, right? You know, we're starting at 41,000. It looks like it's going down and then going back up, right? It goes down. Looks like it might be about the vertex or the minimum. So I'm going to say we probably need to look at it. We're never going to be able to look at it on the axes. So let's go in here. We'll go somewhere around negative 40,000. Not negative 40,000, 40,000. And we'll go up to 50,000. Let's see what that looks like. So let's graph this puppy. On graph. Don't save their crap. Graph. And, wow, this is a crazy one. 345.1, 345.1 x squared minus 1015.4x plus 4153.1. Enter. And clearly you can't see this. So we're going to have to go into the menu. And we're going to go into window zoom, and we're going to set up our window. And like I said, we're going to go from negative 1 to 10. That's about 10 years of check data. And we're going to go from 40,000 to 50,000. Oh, I can see it now. I can see it now. I don't really care what goes on to the left. By the way, you don't see much. So we start here, and we're going to go down, go down, go down, go into a minimum, and then it goes up forever and ever and ever, and everybody's going to die. So, like the range of this would not be till infinity, right? Because not everybody's going to die of AIDS, right? So that's kind of something you got to think about. That's scales. Having a hard time going. Okay, so is that it? I don't think I asked a lot of this before. During what year does the model predict the maximum number of AIDS cases will occur? Did I miss something? I don't think I meant maximum. I meant minimum. Minimum. I'm going to have to change that. So you'll have it changed beforehand. I did thought I changed that. Man, that's crazy. So minimum number of cases. So we're looking for a minimum here. So I'm going to go into menu trace and trace all. And during what year? Menu trace. Not trace all, graph trace. Minimum. Looks like 1.47 years. So that's after 1.47 years. So if 1999 was year 0 and 2000 was year 1 and 2001 was year 2. It happened between 2000 and 2001 was our minimum. Therefore, in what year? The answer would be in the year 2000. Using the quadratic regression model, determine the year in which the number of age cases will be 0. What did I do wrong? I think I might have the wrong table in here. I thought I fixed this problem. There's something wrong with this problem. I have to go back to my notes. But anyway, you can see how we did the regression analysis. Boom, 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 done. And then this stuff is just how to use the calculator. I think we went through a lot of this stuff for you. Sometimes it makes sense to find the axis of symmetry first. A lot of this stuff is just things we did. I just wanted you to have in your notes on some things that we can find. Okay? That's about it. That's about all I want to go over. I'm going to fix this problem before we do it in class. So if you've done it in class, it'll be amazing. If you have the notes, it'll be a little bit slightly different model than this. Okay, kids? See ya. Catch you on the flip side. Bye.